Dear student, I am Manoharpatil. Today we have to solve the MCQs on centripetal acceleration and tangential acceleration. बहुत important topic है, many time they ask the MCQ. So आज का lecture आपको end तक देखना है ताकि आप अच्छे से all MCQ को समझ सकते हैं. So let's me start. Question number first: a body is moving in a circular path with acceleration a. If its speed gets double, मतलब उसका speed double हो रहा है initial से, then what we have to calculate? Then find the ratio of centripetal acceleration after and before the speed is changed. So that is what is given. So let's we consider the initial speed is v1 and then we consider the final speed is v2. What is the final speed? It gets double, मतलब वो 2 times v1 है. So then what we have to calculate? We have to find centripetal acceleration after, then centripetal acceleration before. So as we know that what is the formula of centripetal acceleration? That is a equal to, it is denoted by letter AC or AR, is equal to v square divided by r or r omega square. So according to that we have to select the formula number first, because now here the velocity is given. So therefore taking the ratio of centripetal acceleration after to the centripetal acceleration before, so then what we get, that is v2 square divided by r, then v1 square divided by r. We know that the radius is same, so therefore it will be get cancelled. After that is v1 v2 divided by v1 bracket square and substitute the value of v2. What is the value of v2? The speed is get double of initial, so it becomes, that is 2 times v1 divided by v1 bracket square. So then v1 get cancelled, 2 square, that is 4. So now our option is, that is 4:1. So this is the very simple questions. Take the screenshot of the given example. We go for the next example. A circular orbit of two satellites having radius is given, that is r1 and r2 respectively, and as though that यहाँ पे clearly mention है कि r1 जो है less than r2 है. If the angular velocity of satellite are same, most important statement, that is angular velocity of satellites are same, then their centripetal accelerations are related as. So हमें calculate करना है उसका centripetal acceleration, and these are the options. So now as we know that we try to draw the diagram. There are the two satellites, they are revolving in circular path, and first satellite having radius is r1 and second satellite orbit radius is r2. So this is the first satellite, we consider p1, and this is the second satellite, we consider p2. So what given? r1 is less than r2, and most importantly, if the angular velocities of the satellites are same, means omega 1 is equal to omega 2, and as we know that what is the formula of omega? 2 pi divided by t, means उसका observation, उसका time period same है. So according to that उसकी angular velocity क्या रहेगी? Same रहेगी. And as we know that what we have to calculate, that is centripetal acceleration. What is the formula of centripetal acceleration? That is v square divided by r equal to r omega square. So taking this expression, and then if the omega is constant, so what is our observation? Centripetal acceleration is directly depends on the orbit radius of that satellite revolving in circular orbit. So therefore, so from this observation we can say that if r1 is less than r2, then what about the centripetal acceleration? Centripetal acceleration of first satellite is less than centripetal acceleration of second satellite. Why? Because now here centripetal acceleration is directly proportional to r. अगर r का वैल्यू कम रहेगा तो centripetal acceleration का भी कम रहेगा, और r का वैल्यू अगर ज़्यादा रहेगा तो centripetal acceleration का भी ज़्यादा रहेगा. तो according to that, so which option is correct? That is option number C is the correct explanation of the given example. The बहुत simple question था. Take the screenshot. Next example. A particle is moving on a circular track, मतलब circular का example है. Of radius is given, that is 30 centimeter with constant speed of 6 meter per second. यहाँ पे ये important observation है, constant speed. As we know that what is meant by circular motion, means whenever the object performing that is moving along the circumference of the path. So circumference of the circle, we can say that this is the example of circular motion. There are the two types, uniform circular motion and नॉन यूनिफॉर्म सर्कुलर मोशन. सो व्हाट इज इन द यूनिफॉर्म सर्कुलर मोशन, मतलब स्पीड जब भी कांस्टेंट रहेगा, दैट एग्जांपल वी कॉल यूनिफॉर्म सर्कुलर मोशन. सो दिस इज द केस ऑफ uniform circular motion, and we know that there are the two component of acceleration. One is the tangential component, another one is that is centripetal acceleration. So हमें पता है कि जब भी स्पीड कांस्टेंट रहेगा तो टेंजेंशियल एक्सेलरेशन जो भी रहेगा दैट इज जीरो. फिर व्हाट इज रिमेनिंग एक्सेलरेशन, सो दैट इज AC नॉट इक्वल टू जीरो. सो यहाँ पे हमें सॉल्व करना है AC, क्योंकि क्लियरली मेंशन नहीं है व्हाट वी हैव टू कैलकुलेट टेंजेंशियल और सेंट्रिपिटल. सो हम यहाँ से फाइंड आउट कर सकते हैं. स्पीड कांस्टेंट रहेगा तो ये एग्जांपल बनेगा यूसीएम का, और यूसीएम में टेंजेंशियल एक्सेलरेशन जीरो रहता है और सेंट्रिपिटल एक्सेलरेशन नॉट इक्वल टू जीरो. हमें फार्मूला पता है सेंट्रिपिटल एक्सेलरेशन का. सो दैट इज v स्क्वायर डिवाइडेड बाय r. सो व्हाट इज गिवन, velocity is given, that is 6 square divided by r, radius convert in terms of meters. So इसको हमें मीटर में कन्वर्ट करना है. 6 square means that is 6 into 6 divided by 3, 1 0 get cancel, so that is 10 raised to minus 1 answer. 3 2s are, so that is 2 into 6, 10 raised to minus 1 goes to up, it becomes 10. So what is the product, 6 2s are 12 into 10, that is 120 meter per second square. So this is the final answer of the given example. So the option B is the correct answer. Take the screenshot of the given example. Next example, let AR and AT represent the radial or tangential accelerations. The motion of the particle may be circular. तो ये बहुत ही सिंपल है. मोशन ऑफ द पार्टिकल अगर सर्कुलर रहेगा तो दो ही केस बनेंगे. फर्स्ट उसका बनेगा यूसीएम, यूनिफॉर्म सर्कुलर मोशन, एंड सेकंड विल बी नॉन यूनिफॉर्म सर्कुलर मोशन. सो व्हाट इज द केस ऑफ यूनिफॉर्म सर्कुलर मोशन, हमें पता है यूनिफॉर्म सर्कुलर मोशन में स्पीड कांस्टेंट रहेगा. अगर स्पीड कांस्टेंट रहेगा सो दैट इज AT. व्हाट इज द फार्मूला ऑफ AT, dv by dt. सो चेंज इन वेलोसिटी का आंसर जीरो आएगा, उसकी वजह से AT जीरो हो जाएगा. और AC नॉट इक्वल टू जीरो, बिकॉज हमें पता है कि सेंट्रिपिटल एक्सेलरेशन इज रिक्वायर्ड और इसेंशियल फॉर परफॉर्मिंग द ऑब्जेक्ट सर्कुलर मोशन. So it is essential for performing the object in circular motion. Next, what is a non-UCM? Non-UCM में जो भी speed रहेगा, speed not equal to constant means वो changing रहेगा, varying रहेगा. So therefore tangential component जो भी रहेगा that is dv by dt is equal to not equal to zero. And again we know that AC not equal to zero. Why? पता है हमें कि सेंट्रिपिटल एक्सेलरेशन जो भी रहेगा वो नेसेसरी है फॉर सर्कुलर मोशन. सो मीन्स हु इज रिस्पॉन्सिबल फॉर सर्कुलर मोशन, दैट इज सेंट्रिपिटल एक्सेलरेशन. आपको याद रखना है. सो अकॉर्डिंग टू दैट विच ऑप्शन इज करेक्ट. देखो फर्स्ट में उन्होंने रेडियल कंपोनेंट जीरो बोला है, ये तो पॉसिबल ही नहीं है. सेकेंड में भी जीरो बोला है, नॉट पॉसिबल. ओके, ये पॉसिबल है लेकिन कब, व्हेन द ऑब्जेक्ट इज मूविंग इन यूनिफॉर्म सर्कुलर मोशन, जब उसका स्पीड कांस्टेंट रहेगा. सो दैट इज ऑप्शन नंबर सी इज द करेक्ट आंसर ऑफ द गिवन एग्जांपल. टेक द स्क्रीनशॉट. वी गो फॉर द नेक्स्ट. A particle is moving on circular path of 10 meter radius. At any instant of time, its speed is 5 meter per second and the speed is increasing at the rate of 2 meter per second square. So at that instant, the magnitude of net acceleration will be. So question is very easy. So what is given, that is radius is given, that is 10 meter. Next speed is given, that is 5 meter per second. And the speed is increasing at the rate of 2 meter per second square. मतलब एक इसका आंसर दिया, that is tangential acceleration 2 meter per second square. So we have to solve the net acceleration. So how to calculate the net acceleration? Very simple formula. A equal to under root of AT square plus AC square. So that is equal to under root of AT दिया है, that is 2 square. What we require, that is AC. So how to calculate AC? Try to remember the formula, very simple formula. So that is AC equal to, that is V square divided by R. So substitute the value of velocity and radius, that is 5 square divided by 10. So it becomes, that is 25 divided by 10. So we get, that is 2.5 meter per second square. So therefore we put, that is 2.5 square. So it becomes, after calculating 2 square, that is 4, What is the square of 25? So that is 6 to 5, and now there is a 1, 2.5, so it becomes that is 6.25. So make the addition under root of 10.25. As you know that under root of 10.25 it is near to the 9. What is the square root of 9? That is 3. तो इसका आंसर क्या आएगा? 3 के थोड़ा ऊपर आएगा. So that is 3.2. So now here given, so option A is the correct answer of the given example. So बहुत simple question था, and most important question है. ऐसे question many times they ask into the examination. That is we have to calculate the net acceleration while object performing the circular motion. तो इसको अच्छे से करना है आपको. Take the screenshot. We go for the next. Next example asked into the NEET 2016. The uniform circular disc of radius is 50 centimeter. At the rest we to turn about an axis. Axis के regarding turn हो रहा है, which is perpendicular to its plane. So very simple. This is the circular disc and this is the axis passing through that center. इसके around में वो disc turn हो रहा है, मतलब it's performing the circular motion. So passes through its center. It's subjected to the torque, that is rotational motion, which produces, that is torque essential for the rotation motion, which produces a constant angular acceleration of 2 radian per second square. And then its net acceleration हमें calculate करना है. Net acceleration at the time is given, that is 2 seconds. So first we write down the given data, then we find out the main answer. So what is given? Radius is given, so r equal to 50 centimeter, convert in terms of meter, 5 into 10 raised to minus 2 meter. So इसका आंसर आएगा 5 into 10 raised to minus 1 meter. Next, what given? Angular acceleration is given. It is denoted by letter alpha, that is 2 radian per second square. Then time is given, t equal to 2 seconds. So as we know that what is the formula of angular acceleration? That is omega divided by t, means the rate of change of angular velocity. So that is, so from here we can calculate the value of omega, that is alpha t. So put the value of alpha, that is 2, angular acceleration is 2, and then second time is 2 second, 2 2s are 4 radian per second. So after that we have to calculate the AT and AC. So what is the formula of AC? So that is formula of AC equal to, that is V square divided by R, or R omega square. Out of that, now the omega we already calculate. According to that we have to use this formula. So what is the value of omega? That is 4. So and what is value of R? That is 5 into 10 raised to minus 1. So that is 5 into 10 raised to minus 1 on multiplication, that is 4 square. So what is the 4 square? 16. 16 5s are 80, and then 80 into 10 raised to minus 1. तो क्या आएगा फिर आंसर फाइनल? दैट इज 8 into 10 raised to minus 1, मतलब 0 और minus 1 get cancel, remaining only 8 meter per second square. Then what about the tangential acceleration? So that is r alpha. So r is given 5 into 10 raised to minus 1, alpha already given, that is 2 radian per second square. So 2 5 2s are 10 into 10 raised to minus 1, 0 0 get cancel, 1 meter per second square. As we know that what is the formula of net acceleration? Both simple है. So that is equal to under root of AT square plus AC square. So that is under root of, that is 8 square plus 1 square. So it becomes, that is under root of 64 plus 1. So it becomes, that is 65. And as we know that 65 under root is, it is near equal to 8. So option में अच्छे से देखना है. That is option D. So near equal to 8 मीटर पर सेकेंड स्क्वायर. सो बहुत इजी क्वेश्चन था, अच्छे से इसको कंप्लीट करना है जल्दी. टेक द स्क्रीनशॉट. वी गो फॉर द नेक्स्ट. नेक्स्ट एग्जांपल. इन द गिवन फिगर acceleration is given, that is 15 meter per second square. Represent the total acceleration, means that is the net acceleration of the particle moving in the clockwise directions in a circle of radius भी दिया है उसका 2.5 meter at the given instant of time. Then speed of the particle is, तो diagram दिया है उन्होंने, very simple है to solve. So now we try. So that is, now this is the particle is performing the circular motion. It is moving along in clockwise sense. So this is the AC, means centripetal acceleration, direction of centripetal acceleration toward the center. This is the AT, that is tangential acceleration, and this is the net acceleration, that is A. So therefore we draw the parallel vector here. So after draw the parallel vector, we get the one triangle. One triangle is formed. What is the angle between them? That is 30 degrees. So for that, AC is the adjacent side and AT is the opposite side. So therefore for adjacent side, how to calculate? So that is by using the cos. So we have to calculate the cos 30. So that is cos 30 equal to what? Adjacent side upon hypotenuse. So adjacent side है आपका AC और hypotenuse है आपका net acceleration. So यहाँ से AC का आंसर आएगा, that is A cos of 30. And as we know that what is the AC? V square divided by R. So therefore A cos of 30. So then V square equal to A R cos of 30. So that is A. Net acceleration is given 15. Then radius is given. What is the radius? 2.5 meter. 2.5 meter, and after that cos 30 degree. What is the value of cos 30 degree? जल्दी से recap करना है आपको. What is the value? That is root 3 by 2. So after that we have to calculate, and taking the square root of that example, so that is 15 on multiplication 2.5 into root 3 by 2. तो इसको जल्दी से calculate करना है, बहुत easy है. So after calculate, so now we get the 5.7. So this is the answer of the given example. तो बहुत simple example था. तो आई होप आपको सभी को अच्छे से एमसीक्यू समझ में आ गए होंगे. सो बहुत इंपॉर्टेंट एमसीक्यू थे. सेंट्रिपेटल एक्सेलरेशन जो भी टॉपिक है, हमेशा उस पर क्वेश्चन पूछे ही जाते हैं. अगर आपको कुछ भी डाउट रहेगा तो डेफिनेटली मुझे टेक्स्ट करना है. और मोस्ट इंपॉर्टेंटली, अगर आपने अभी तक इसको सब्सक्राइब नहीं किया है तो प्लीज़ इसको सब्सक्राइब कीजिए, शेयर कीजिए और कमेंट जरूर करना है. थैंक यू वेरी मच.